Today, we will be learning how to solve non-right triangles using the law of cosines. As you can see here, this triangle does not have a 90-degree angle, meaning that we can't solve it using the Pythagorean theorem or basic right triangle trigonometry. However, what we can use is something called the law of cosines. The formula for the law of cosines is this, and if you can notice, it's kind of like an extension of the Pythagorean theorem. What this law does is that it relates the three sides and any angle in a triangle, and it allows us to solve for any non-right triangle as long as these conditions are present. Either we are given all of the three side lengths of the triangle, or we are given two side lengths as well as an included angle, which actually matches the appearance of our triangle right here. And as you can see, these are the two side lengths and this is the included angle. So now, let's use this law to solve our triangle. I'm going to make x here our c value because it's the side length we want to solve for. And I'm going to make this 55 our a value and this 55 our b value because they are the side lengths that include our angle 61 here. Now let's plug each value into our equation. So we're getting x squared is equal to 55 squared plus 50 squared minus 2 multiplied by 55 multiplied by 50 multiplied by the cosine of 61. And now all we have to do is solve this equation. So 55 squared is just 5,025 and 50 squared is just 2,500 and negative 2 multiplied by 55 multiplied by 50 is just negative 5,500 times the cosine of 61. And now 3,025 plus 2,500 is just 5,525, which is then subtracted by 5,500 multiplied by the cosine of 61. And now I will just take the square root of both sides of our equation to remove the square on the x. And this will leave me with x is equal to the square root of 5,525 minus 5,500 multiplied by the cosine of 61. And that is our exact solution. And if you use the calculator, this is equivalent to approximately 53.46. And that's our solution to this problem using the law of cosines. I hope you learned something new today, and thanks for watching.